Here's pre-calc. This is number 7-130. We were doing this in class, and it was about this plane that was flying with an airspeed of 540 miles per hour in this direction, and it encounters a wind. So we found the true speed and direction of the plane by adding the component form of the vectors for the airspeed of the plane, and we added those to the component form of the vectors of the wind, and then we put it back in polar form, and I think I have all that written here. We ended up with this is the miles per hour, and this is the direction of the plane when it's being pushed by the wind. Okay, and then on letter B it asked us how long will it take the plane to travel 1,000 miles, and the resultant means you added the forces. How long will it take the plane to travel 1,000 miles in the resultant direction? So we got that it was 566.97 miles per hour, and we know distance equals rate times time. So we want to know how long for 1,000, so we put in 1,000 for the distance, and then divide both sides by the rate, and then that gives us the time. So it would, for the plane to go 1,000 miles, it would take 1.764 hours. Now letter C said if the pilot intended to fly 1,000 miles in the direction north, how do we say that, 45 degrees east of north, how far from his intended destination is he given the situation in part B? That was the part that I couldn't understand. And I tried to understand, and I finally figured out what this means is without the wind. So if the plane he was planning on, he knows his plane goes 540 miles per hour, and he knows what direction he wants to go. And if he just plans on that without taking into any account the wind, that could be his intended destination. So I think all we have to do is calculate, where he would end up if he didn't encounter that wind, like make a vector for it, and then make another vector. Well, we already have the vector for the one that takes into account the wind, and then we'll draw a line between them and find that. So I'll show you what I mean. So this is what I think needs to happen. We have if the plane did not encounter any wind, it would just go 540 miles per hour, and it would be there'd be a 45 degree angle. Like, so I know they made their angle up here because this was north and this was east, but if it's 45 here, it's 45 down here also. So then we just can do some calculations if we want to find the components. And then this one, well, we already did all this resultant vector. But what I want to do is, instead of having this just be 540, I'm going to make this 1,000, both of these. I want to make them 1,000, and then I'm going to get the component vectors, and I'm going to find this distance right here. Okay, so how are we going to do that? So here's a little drawing that I made. But I think I drew it again right here. I drew it again right here. So, it already smeared. So, if I go in this direction for 1,000 miles, well, I can still find these component vectors, because I know this was remember this black triangle, that was the original, like without the wind speed, that was 45 degrees right there. So I can find this length by saying 1,000 times, here, I'll do it here, 1,000 times cosine of 45, and this I could get by 1,000 times sine of 45. I don't really want to clutter up my picture too much, but let's find some numbers for that. So 1,000 cosine 45. It's like about 70, I'm going to call it 707.1, I suppose. So I'm going to say this line right here, 707.1. And I know sine of 45 is going to be the same as cosine of 45, so I'm going to say this one's also 7.1. So that's this length and this length. So actually this point right here, I'm already messing up my picture. This point right here is 707.1, comma 707.1, isn't it? Like the X and Y. And then I'll make another, so I'm going to connect these points right here, this from here to here. And that's going to be the difference between his intended destination and his actual destination. So how can I get some numbers for my red triangle? Well, this one, if you remember, we had in our answer, it was like 48.99 degrees because we were saying east of north or whatever. But I don't really want that angle. I want my little math angle. I'll call it the math angle. The math angle was 41 what was it? 41.0 something. 41.01. And so what I'm going to do is get these ordered pairs for here by finding cosine. I'm going to say 1,000 times cosine of 41.01. And I got 754, I guess I'll call it 754.6. And then this side right here is going to be sine. It's going to be, because what I'm doing is I'm going like sine of 41.01 is opposite over hypotenuse. Right, and that's why I keep saying it's 1,000 times. If I multiply both sides by 1,000, that gives me 1,000 times sine of 41.01 is equal to x. So I want to know what that is. So 1,000 sine 41.01. And we've got 656, I guess I'll call it 656.2. Okay, and then, so now I've got these, like, the component form, they're ordered, I made them as ordered pairs, but they're also the component forms of the vectors. And then I think I'm just going to subtract them because the question says, if the pilot intended to fly 1,000 miles in the direction, you know, the original, the black direction, how far from his intended destination is he given the situation in part B? Well, in part B we know because of the wind he ended up over here. This red one is where he ended up. Remember, we did all that work with the resultant. We had to find the resultant vector, like we had to take into account the wind speed. So this is where he actually ended up. This is where he intended to if there wouldn't have been a wind. So all I really want to know is, I'm making a tiny triangle. I want to know the hypotenuse of that tiny triangle. So what I'm going to do is subtract, you know, my ordered pairs. So I'm going to go 707.1 minus 754.6, and I'll try to write it so that you can actually, maybe I'll write it down here so you can see it. Okay, 7 minus 754.6. So if I take this one and subtract this one, I end up with negative 47.5. And then if I subtract the y values, I'm doing that so I can get these little sides of this right triangle, and then I can use Pythagorean theorem to get this little teeny hypotenuse right here. I want that distance right there. So let's try 707.1 607.1 minus this little number is 656.2. That gives me about 50.9. And so I think that those are the sides of the triangle. So if I go a squared plus b squared equals c squared, so that's, I'm going to square this one first because it's already in my calculator. So I squared both of them and added them together, and then I'm going to take the square root of the answer, and that's going to give me this distance right here, which is the difference between where he wanted to go and where he did go, is 69.6 miles. And let me check and make sure that's right. Yeah, they got 69.56, so that rounds to what I got. And I think that's all I got for you.